Hello friends, today we'll see how to interface with the 7 segment display using 8051 microcontroller. For the same purpose, open your Proteus 8 Professional. Now click on new project, open the project, give name to your particular project. I have here given the name as 7 seg. Now click on next. If you want to change the directory where you want to store the data, the file, you can change it. Now click on next. Now the Proteus design suite is open. Here we need to select the component. Click on component P, give name of your particular microcontroller that you want to use, 889C51. Select that, then select the 7 segment display. Now there are two type of 7 segment displays available. One is anode, common anode, and second is common cathode. Here I am using common anode 7 segment display. Now place your microcontroller somewhere on the screen. Now place your 7 segment display. Here we are using common anode. In case of common anode, the enable pin is connected to VCC. In case of common cathode, the enable pin is connected to ground. So here we'll place the terminal power, connect that to RST as well as the 9th pin of your 7 segment display. Now it's time to connect the port P1 pins, P1.0, P1.1, P1.2, P1.3, P1.4, 5, 6 and 7 to various pins of the 7 segment display. And for that particular purpose, now we have connected pin number 1 of 7 segment display to P1.0, pin number 2 to P1.1. Similarly, we are going to connect all 8 pins of 7 segment display to our port P1 various pins. Now one thing that we need to remember here is basically to display any particular data using the 7 segment display, we need only 7 pins, but here one extra pin is available, pin number 1. In case of common anode and common cathode, we need to put various values. Like in common anode connection, we are putting the pin number H as 1. In case of common cathode, we are putting that as 0. That we'll see later in the same tutorial. Now it's time to write the program. Open the Keil Microvision software. Whatever projects are open, close the project. Now create a new project, give name to your project, as I have given it as 7 seg. Now it will ask you to select the particular microcontroller. Select 8089S51. Right click on target, option for target 1, click on output and create the hex file. This second setting you have to do every time. Now the source group is created. There we need to add some file. So click on file, new, save the file, give some name 7seg. Now here you need to put the extension .c, that you need to remember always. Now you can start writing your program. So first of all, we need to call the preprocessor directives, and for that I am using reg51 because I have used 8089C51, the MCS51 family microcontroller. So for that, preprocessor directive is reg51.h void main. Here in this particular program, basically we need to declare some variables. The first variable that we need is for the numbers from 0 to 9, total 10 numbers we want to display on 7 segment display. So for that we need to count that. For that we will define one variable that is unsigned char x, and we want some delay in between when we are going to display the numbers on the 7 segment. So that time we want some delay between 1 to 2 number, like 0 1 2 3. We want some delay. For that we have defined here unsigned int I. Now we need to define one array where we are going to put the values to display the numbers from 0 to 9, and for that I have defined the variable character. The variable name, array name is seg, and I have 10 values, so that I will define as 10. Now we need to give the particular value of 0 to 9, and for that particular, you can see here there are two connections. For common anode connection, we need to put 0 to enable a particular LED segment like A, B, C, D, E, F. If you want to put 0, then A, B, C, D, E, F should be 0, and only G should be 1. In case of common anode connection, we always put the value of H as 1, and similarly we can see. So if you want to put 0, you can see from here that the values of A, B, C, D, E, F will be 0, and G and H will be 1. So 1 1 0 0 will be C, and 0 0 0 0 will be 0. So for displaying 0, we need to put the value of port P1 as C0, 0x C0, you can see from here. Similarly, for common cathode connection, we put always 1 to enable a particular LED segment, and if we want to put 0, the values of A, B, C, D, E, F, G, H will be 0x3f. How that we'll see. Here one thing we need to remember, that the value of H should always be 0, and we can see the example that A, B, C, D, E, F we are putting as 1 to enable the value, and G and H we are putting as 0. So here the value that to display 0 will be 3f. So in that way we'll write the code for each and every particular number from 0 to 9, and that we need to assign to particular port P1 with some delay. So here I am going to assign the value. One thing you need to remember, in whatever sequence you are writing in this here in the array, in the same sequence the 7 segment display is going to show you the output. So from 0 to 9 in same sequence we need to put the data. Here for 0 it's 0x C0, 0x is for hexadecimal representation, for 1 0x F9, for 2 0x A4, for 3 0x B0, and so on. Similarly we can put the values for all the numbers from 0 to 9. If you'll make any mistake, it will show you the content will be shown in black. So in that way we'll come to know that there is a mistake. Now we want that the numbers from 0 to 9 will display forever, and for that we'll use one infinite loop by using while 1, or you can also use empty for loop. Now at the beginning we want that the P1 should behave like an input port, and for that we have put the value of P1 as 0 0. Now we want to put the values from 0 to 9 that we have stored in our array segment 10. So for that particular we'll initialize one loop for x equals to 0 to x is less than 10 x plus plus. There we are going to put the value of array. When the value of the x will be 0, then it will provide port P1 0x C0, and the 7 segment display will display the 0 value on the screen. So in the same way we have defined p1 is equals to seg x. Now we want that between two consecutive number there should be some delay, so we will define the delay. For that we'll use one for loop. For I is equals to 0, I less than 50,000, I plus plus. Now close all the open brackets. Our program is done. If you'll make any mistake, it will show you the error during the execution, but before that you save your program. Now click on build target. If there will be any error, it will show you. Now the error is we have not included the seg.c file, so that we need to include. Select the file seg.c and add in source group 1. Now you can run your program again. Zero error, zero warning. Now we'll upload the program into our microcontroller. Double click on the microcontroller. Select the particular file wherever you have stored. File name is 7sec.hex. Open it, click on OK. Now you are ready. Run the program. Now you can see here the values from 0 to 9 is displayed on the 7 segment LED with some delay. Thanks for watching my YouTube channel.